Hey guys, today we're going to learn about literal equations. So, a literal equation is kind of similar to what we've been doing as far as solving equations, except now instead of just having, like for example, we could solve 3x is equal to 12 and we could solve for x. A literal equation actually has numbers and variables. So you could have more than one variable or you could have all variables. Like let's think about the area of a rectangle. Area equals the length times the width. Okay, so that's the formula for the area of a rectangle. All right, so last unit or a couple units ago when we talked about equations, we can easily solve 3x equals 12 by dividing both sides by 3 because of the division property of equality. We did that and we would get x is equal to 4. Okay, a literal equation works the same way. Now our whole goal is to isolate the variable. So in this case we isolated for x and we solved for x. When you have a literal equation, you'll have a formula and the directions might say something like solve for w. Okay, so what that means is you're going to isolate the w variable, okay, which in this case is right here. Okay, you want that w to be by itself. Okay, so in order to do that, if I'm solving for w, I might start out and actually get the w on the left side. Okay, and how I do that is I just flip the equation. So I have LW is equal to A. Okay, and my w is here on the left. Okay, and you don't have to do that. You can keep it on the right and solve for w on the right. I prefer my variable to be on the left. Okay, so I just switched, didn't change anything with the order, just switched on either side of the equal sign. Okay, so now to get w by itself, I'm just going to do right here, LW together means multiplication, so I do the inverse operation, which is division. So I'm going to divide by L. Whatever I do to one side of the equation, I have to do to the other. Okay, so again, it's the division property of equality. Okay, L divided by L is just 1, and we're left with W is equal to A divided by L, and that's our answer. Okay, so we can't really do a check step with literal equations because we don't have any numbers. All right, so let me give you another example here. So this one was pretty basic. We just had we just had one term here on either side. Okay, so now what if I have multiple terms? Okay, meaning let me have an example. Say we had 2x plus 3 is equal to 11. All right, so our familiar way of solving an equation. Okay, on the left side, and on the right side, I'm going to give you a formula. This is actually the equation of a line, mx plus b. Okay, so on the left we have we're just going to solve for x, and we would do that by subtracting 3. So we first get rid of the other term, and we do that by either adding or subtracting, doing the opposite. So when we do that, we end up with 2x is equal to 8. Okay, and then the next step would be to divide both sides by 2. Okay, we do that, the 2's cancel it out, we're left with x is equal to 4. Okay, so with this kind of equation, we can actually plug it back in and do the check step and verify that x is equal to 4. Now on the right side, our literal equation, it might say something like solve for x. Okay, if I solve for x, okay, all right, it means I want to get that variable all by itself. I need to isolate that variable. So I'm going to start out and I'm just going to switch the order again. I'm just going to take everything on the right, move it to the left. Mx plus b is equal to y. Okay, so I want to solve for x. All right, the first thing I'm going to do is look at my other terms. So on the left side, I have mx plus b. So I want to first get rid of this other term. I'm going to just do that by subtracting. Okay, I'm going to subtract both sides. I'm going to subtract b from both sides. So when I do that, I end up with mx, this would cancel out, is equal to y minus b. Well, I can't do anything. They're not like terms, so it's just mx is equal to y minus b. Okay? All right, and I'm going to then get x by itself. So in order to do that, I want to divide both sides by m. Okay, because m divided by m is 1. Whatever I do to one side of the equation, I have to do to the other. So that would cancel out, and I would be left with x is equal to y minus b divided by m. Okay, so that would be my answer. All right, let's look at what would happen if I decided to not solve for x, but maybe solve for b. Okay, I'm going to erase all this and show you the difference. Okay, so in this case, I'm going to say, okay, instead of solving for x, I want to solve for b. Okay, so if I do that, I'm going to solve for b. I'm going to rewrite this now as mx plus b is equal to y. All right, and now I'm solving for b, so I want b to be by itself, right? Okay, so I have this other term, mx. All I have to do is subtract mx from both sides of my equation, and then b would be by itself. Okay, so then I would be left with b is equal to y minus mx. And that would be my answer. Okay, so we're going to go through the notes and try some different examples, and we'll see how we do with it. Well, actually, before we do that, let me just try. I talked to your science teachers, and I talked a little bit about literal equations, and I kind of wanted to incorporate, kinetic and potential energy. So kinetic energy is K is equal to 1/2 the mass times the velocity squared. Okay, what if I wanted to solve for the mass? Okay, what would I have to do to get m by itself? Well, I'm going to start out and I'm going to flip sides. mv squared is equal to k. Okay, my whole goal is to get m by itself. All right, so when I have a fraction here, 1/2, how can I get rid of that fraction? I'm going to multiply both sides by 2. Okay, so then I'm left with mv squared is equal to 2k, or k2. All right, I want m by itself, so now all I have to do is divide both sides by v squared. Because v squared is divided by v squared is 1. They would cancel out. We would be left with m is equal to 2k divided by v squared. Okay, so that's if we solve for m. All right, say we took the same formula and this time we decided to solve for v. That gets a little bit more complicated. So let's look at this. K is equal to 1/2 mv squared. Okay, so now we're solving for v. Again, I'm going to just switch it so that my v is on the left side. Okay, just switch these around. Okay, I want v to be by itself. Well, I'm still going to multiply both sides by 2 to get rid of my fraction. So I end up with mv squared is equal to 2k. Always put your coefficient first. Okay, I want my v by itself, so I'm going to divide both sides by my m. Okay, so now I've got v squared is equal to 2k divided by m. All right, now this is where it gets a little tricky. We're solving for v here in this example. Over here we solve for m. Here we're solving for v. Okay, because v is squared, I actually want to do the inverse operation. So instead of squaring, I'm going to take the square root. Okay, the square root of v squared is just v. Now whatever I do to one side of the equation, I have to do to the other. So when I do that, at this point, we would end up with v is equal to the square root of 2 times k divided by m. Okay, so that was an example using kinetic energy. All right, let's go